Amanda Crowther. I was in charge of the electrical portion of this whiteboard assembly.
Hey, I'm Andrew Roth. I was in charge of the CAD design as well as assembly of this machine.
I'm Nicholas Hobart. I was in charge of the pneumatic design, engineering, and assembly of this automated whiteboard cleaner. So for our project, we chose to do a automated whiteboard cleaner. We had a couple different designs set in place, but we had like a cylinder draw, but in the end we decided to go with a clamping system and 2 electric motors to drive it back and forth. We also have a automated sprayer so that it can spray down the board. And we have spring tensioners pushing down on the erasers so that you're actually able to wipe something off. We kind of thought this is good for teachers who can't reach up high, or if they just want to push a button and have it go back, wipe, and then come back. We have 2 separate modes. We have an auto mode and a manual mode. So in auto mode, we have 2 inductive proc sensors here. When you push the green push button, it'll go down, sense that there's these end panels here, stop, and then come back. And then in the manual mode, there's a left and a right button, so you can just run it left or run it right. And then in the manual mode for the sprayer, there's a push button for it. And in the auto mode, it's on a timer. So the pneumatics for this project were probably the simplest to prepare and design and engineer. Just a quick overview. We have a regulator, 2-position 3-way solenoid operated directional control valve with a spring return. And then we have a flow control that's controlling the cylinder's speed. This is a single acting cylinder. It's normally retracted. And that's pretty much all there is to the pneumatics. When I was designing the schematic, this is what I came up with. So as you can see, you have your regulator here, your solenoid valve, your flow control, and then your cylinder. So pretty basic. And then for bringing it all together, I went into SolidWorks and designed this mechanical assembly. I wanted to put the cylinder on some shims so that when it hit the pump, it was level with it. And then, of course, it had to have a back plate. This was relatively easy. I came into some complications, but I was able to figure it out. Upon the assembly of this, we essentially first we're going to use this manual pump in place of this Windex bottle. So we're going to put it in there and then have the cylinder actuating it. But we came into some leakage issues, so we had to improvise and use that. And this is connected right from the sprayer, and it goes from a hose all the way to the actual clamping assembly, and it's just running underneath here. We drilled some very small holes in the tube so that when we actuated the sprayer, it would drip on the whiteboard. And that's pretty much all there was to the pneumatic.
So I was in charge of the CAD design of this project. We had 8 weeks to design this and 8 weeks to build it. So this is the board, the arm that is clamped onto this whiteboard assembly. Here we have the electrical panel. This is the ball screw assembly. Normally you'd actually use a professionally made ball screw assembly, but our budget did not allow for that. So in order to get the clamping force of a ball screw assembly, I improvised and made my own ball screw assembly out of 2 bolts partially threaded and 1 fully threaded bolt with a handle on it. This gives the exact same effect as a ball screw assembly, but without the inflated cost. Next is our spring assembly. We used some wide end springs to press against the plastic panel on the board. And these are our 3D printed part, which then bites into the eraser with its teeth. This ensures that it has even pressure along the whiteboard assembly as a whole. And that's pretty much everything with the CAD design.